Hello friends, and welcome to Webronaq. You tap your laptop touchpad dozens of times a day, but in April 2026, something new arrived. Microsoft pushed Windows 11 Insider builds, starting with build 26300.8155 in the dev channel, that let your touchpad physically buzz back at you. Snap a window into place, and you feel a tiny pulse. Hover over the close button and the pad ticks. You can turn it on and off in settings, under Bluetooth and devices, then mouse, then haptic signals. That one update pulled back the curtain on something most people never think about, which is the full stack that runs from a finger touching a glass surface all the way up to a Windows gesture event. In this video, we are going to walk every layer of that pipeline, and by the end you will understand exactly how your laptop knows where your finger is and what to do about it. Alright, so now you know the big picture. Let me walk you through what is actually happening at the hardware level. Your touchpad is not a single sensor. It is a layered sandwich of materials, and each layer has a specific job. At the bottom you have the base PCB, which is the printed circuit board that holds all the controller electronics. Above that sits the electrode layer, a grid of microscopic copper traces, etched into a flexible film. Then comes a thin dielectric layer, which is an insulating material that separates the electrodes from anything above. And finally on top, the glass or plastic cover that your finger actually touches. The controller chip, often from a company like Synaptics, Elon, or Alps, sits on that base PCB and is responsible for driving signals through the electrodes and reading back the capacitance changes. Each layer's tolerances are tuned to within microns. That precision is what allows the system to detect a fingertip that might only be a few millimeters wide. Now that we know what the hardware looks like, let us see how it actually detects your finger. Here is the interesting part. Your touchpad detects your finger without you pressing anything at all. Here is how. Under the glass surface sits a grid of tiny metal electrodes. The touchpad controller sends an alternating electrical signal through those electrodes at roughly 200 to 300 kHz, which is fast enough to create a stable electrostatic field just above the surface. Now, your finger is conductive. Your skin holds charge. The moment your finger enters that field, it draws some of the electric field lines toward itself, which reduces the capacitance measured at the nearby sense electrodes. Capacitance is simply a measure of how much charge two conductors store between them. When your finger disturbs the field, that stored charge drops, and the controller chip detects the change instantly. No click, no pressure, just a measurable shift in an electrical value. That same principle scales up to dozens of contact points at once, and to understand how, we need to look at the electrode grid itself. Now look at this. The electrode grid under your touchpad is not just one big sensor. It is organized into rows running left to right and columns running top to bottom, crossing each other like a city street map. At every intersection, the controller chip can measure the capacitance independently. When your finger hovers near a specific crossing, the capacitance at that node drops. The chip scans every row and every column in sequence, building a full map of which intersections changed. From that map, it can calculate the exact X and Y coordinates of your finger, precisely, in real time. Here is the truly powerful part. Because every intersection is measured on its own, two fingers in completely different spots, each create their own pattern of reduced readings, and the chip can track both simultaneously. That is how true multi-touch works. No guessing, no averaging. A dedicated grid of measurements, one for each crossing point. Up next, let us see how the chip turns that grid scan into data Windows can actually use. Alright, so the grid scan gives you a raw map of capacitance changes. But how does that become a cursor move on screen? That is the controller IC's job. This small dedicated chip sits on the touchpad circuit board and runs the grid scan at roughly 100 to 250 times per second. Each pass reads every row-column intersection, converts the analog capacitance readings to digital values, and calculates the position and size of each contact point. Then it packages that information into a standardized HID report. HID stands for Human Interface Device, a protocol that Windows understands natively. Each report is a small data packet containing a contact ID, the X and Y coordinates, the contact width, and a timestamp. The chip sends those packets to the laptop's main processor over a bus, typically I2C for internal touchpads, or USB for external ones. Windows receives each packet through its built-in HID class driver, with no custom code required from the touchpad vendor. That clean, standardized handoff is exactly what the next layer of the pipeline depends on. Here is where the software side of the pipeline gets really interesting. On a legacy touchpad, the vendor driver handles everything: palm rejection, scroll direction, pinch detection. The problem is that every manufacturer does it differently, so the same gesture can feel completely inconsistent from one laptop to the next. Microsoft's Precision Touchpad specification fixes that by moving gesture logic into Windows itself. A certified Precision Touchpad sends only raw contact data upward, and Windows owns every decision from there. Which touch is a resting palm? Which two-finger movement is a scroll? Which three-finger swipe opens the task view? You can see exactly this principle playing out right now in real hardware. Acer's Swift 16 AI, revealed at CES 2026 with the world's largest haptic touchpad, is a precision touchpad device. And in April 2026, Windows 11 builds 26,220, 20.8148 and 26,300.8155 added oxygen mono-sulfide level haptic signals to that stack, letting Windows itself trigger subtle vibrations when you snap a window or hover over the close button, all configurable under Settings, Bluetooth and Devices, Mouse, Haptic Signals. That brings us to the full picture of the pipeline, from finger to cursor and back again. And with that, we have traced the complete journey. A finger lands on the glass. Capacitive sensors record a change in charge. The ASIC converts raw capacitance into X and Y coordinates and packages them as HID reports. The USB or I2C controller hands those packets off to the OS, which feeds them through the driver stack into the cursor, the scroll buffer, or the gesture engine, and your display responds in real time. The key takeaway is this: every touchpad interaction is a pipeline, not a single event. Hardware reads the physical world. Firmware abstracts it into data. The OS interprets that data as intent, and the application acts on it. Understanding that pipeline tells you exactly where to look when something goes wrong. Is the ASIC miscalibrated? Is the driver stack dropping events? Is the gesture recognizer misclassifying a touch? Thanks for watching. If you found this useful, like and subscribe to Webronaq, and drop a question in the comments. See you in the next one.